We have another challenging geometry math question, and I want us to do this together. Welcome back to my channel. So today we are asked to find the value of r. Let's assume this is the center of the circle. So we are asked to find the value of r. That is the radius of this circle. First of all, I would like to join this point to this point. Okay, this point to this point, sorry. But first of all, I will have A. Let's name the points B, C, D, E. So I want to join point E to point B, right? Okay, now note that DB is equal to DE. Why? Because both of them are radii of this quadrant DEB. Okay, radii, or they are radius, radii for plural. So if we say let DB be equal to x, this implies that DE is also equal to x. So I'll label this x and I'll label this x. Now note again that BE is equal to 2 centimeters. Why? Because it is the radius of the bigger quadrant, right? Radius. This is the radius of ABC. Quadrant ABC. So because we are told that AB is 2 cm, that means that BE should also be 2 cm, since point B is the center of the quadrant, right? All right. Now, having established that fact, so this place is 2 cm. Now let us consider triangle BDE. We have triangle BDE. So this is D, right angled. This is E, and this is B. So we have X here and we have X here, and this is 2 cm. Now using Pythagorean theorem, we have x squared plus x squared is equal to 2 squared, the hypotenuse squared. Now x squared plus x squared is 2x squared is equal to 4. Let's divide both sides by 2. So we have x squared is equal to 2. So if we take square root of both sides, we will have that x is equal to square root of 2. All right, so I'm going to replace this x and this x with root 2 to avoid confusion henceforth. All right, now I don't need this anymore, and because I don't want my diagram to look so clustered up, I'll be deleting the line. All right, now I will be joining this particular B to this point. Now let's call the point of contact between this smaller circle and the big quadrant. Let's call the point of contact F. Remember that this is not drawn to scale, okay? So our drawing may not really be perfect, but I just want to ensure that we all understood what I'm doing. Okay, so let me join the point. Okay, Now, I want us to recall this theorem that states that when two circles touch each other, right? When two circles touch each other, their point of contact and their centers are on a straight line. Okay, now this is the center of this quadrant, the bigger quadrant ABC. This is the center. This is the center of the smaller circle, and this is their point of contact. So they are supposed to be on a straight line with regards to that theorem. All right, so that simply means that let us call this, let's drop a perpendicular. Okay, and this is going to give us 90 degrees. The truth remains that BC is a tangent. BC is a tangent. And when you drop a straight line from the center to the point of contact between a tangent and a circle, 90 degrees is formed. So definitely this is 90 degrees. Okay, now remember that from here to here, let's go from here to here y. All right, then from here to here is r. Now remember that BF is also the radius of BAC, right? BF is radius of quadrant BAC, this B quadrant. Therefore, this implies that BF should be equal to what? 2 cm. Okay, so from here to here is 2 cm. Let's call this 0. So if we want B0, BO will be equal to BF minus, from here to here is our radius, right? Minus R. That means that BO will be equal to 2 cm minus R. So I'm going to label here 2 minus R. All right, now let's consider triangle BO. Let's call this K. BOK. BOK. All right. If this is the first time you are coming across this lovely channel, please subscribe to the channel, turn on your notification bell so that you don't miss our videos, right? We upload our videos as often as possible. Tune in at your convenience. There must be something new for you to watch by God's grace. Give us a thumbs up if you love what we are doing. All right, so now let's consider triangle BOK. Triangle BOK is like this, and like this. BOK. And we have 2R. Here is 2 minus R. Here is Y. And here is R. And this is 90 degrees. Now, using the Pythagorean theorem, we have that y squared plus r squared is equal to 2 minus r. So we have y squared is equal to, so 2 minus r squared, sorry. So y squared is equal to 2 minus r squared minus r squared. That is if I take this to the other side. So remember that a minus b all squared is equal to a squared plus minus 2ab plus b squared. A squared minus 2ab plus b squared. My shout out today goes to Justa1000. Thank you for your suggestion on me always erasing out where I clean the board. I will implement that, but I'll rather fast forward than erase it. I think that one is better. Thank you so much. So always comment. We are there reading and we are going to reply when necessary. All right. Thank you so much. Now, look at this. We have y squared is equal to, so this is going to be 2 squared, which is 4, minus 2 times r, which is 4r, plus r squared minus r squared. Now, plus r squared minus r squared is 0. So we now have y squared is equal to 4 minus 4r. Very important. So I'm going to write it. Y squared is equal to 4 minus 4r. So I think I don't need this anymore. So I will be erasing this. Remember why? Because I don't want this particular diagram, you know, it is small, to be chopped up. All right. Okay. So we are going to join this particular point here, a perpendicular. Let's drop a perpendicular on BD from 0. Let's drop a perpendicular on BD from 0. Emphasis on perpendicular. All right. Having done that, let's call this place H. So HO will be equal to our Y, right? So I'll write Y here. Now, we're almost at the end of this video. Yes, really. Now, HB is equal to R. HB is equal to R. So we label this R. Now, from D to B is root 2, right? From D to B is root 2. Root 2, sorry. So that simply means that DH is root 2 minus R. All right? DH is root 2 minus R. So this root 2, I'm going to clean it now because this is for your DB. Is root 2 for your DB. Now DH will be root 2 minus R, this line. Okay, now let us join D to O through C. That is because we are going to make use of the same theorem that states that when two circles meet each other or touch each other at a point, then their centers and their point of contact line on a straight line. So the center of DEB, which is this quadrant, and this circle, the center of DEB is D, and this is their point of contact, and this is the center of this circle. All must line on a straight line. So let's do that. All right. Now we have formed another triangle, and this is where we are going to be getting our result from. Look, remember that from here to here, let's call this point M. All right. From M to O is R, right? And from D to M is the radius of this smaller circle, radius of this quadrant, which is what? Root 2. So here is going to be, that means that D to R will be root 2 plus R, right? Root 2 plus R. So I'm going to draw out this particular right angle now. So drawing it out, we have DH, and we have what? This place is our O, center O. So DO is root 2 plus R. And DH is root 2 minus R. And HO is our Y. This is what? 90 degrees, because emphasis on perpendicular when we dropped the straight line. Now, using Pythagorean theorem, you can see that root 2 minus R all squared plus Y squared is equal to root 2 plus R squared. Now, if we expand this, we are going to have root 2 squared. I need to write this somewhere. Okay. So we are going to have root 2 squared minus 2 multiplied by root 2R plus R squared, if we expand this. Then plus Y squared is equal to, this is root 2 squared as well, plus 2 root 2R plus R squared. I just hope you can still see that side. Okay, I think I need to bring down my hand from here. So now we have root 2 squared. This, we remove this, we have only 2. So we have 2 minus 2 root 2R, 2 root 2R plus R squared plus R squared plus Y squared plus Y squared is equal to root 2 squared is also 2 plus 2 root 2R plus R squared. So we have R squared here, let's go ahead and remove them. And we have 2 here and 2 here. Both of them will go, right? Because if I should transfer them to this side, this becomes 2 minus 2. So it will go. And arrow squared, this arrow squared will come and become minus arrow squared. It will still go. So now we are left with minus 2 root 2r, okay, plus y squared is equal to 2 root 2r. Remember that our y squared is equal to 4 minus 4r, right? Yes, our y squared is 4 minus 4r. So we substitute. We will have minus 2 root 2r plus 4 minus 4r is equal to 2 root 2r. I'm sorry I cleaned this. We wrote it down somewhere and I mistakenly erased it. Now, let us transfer this to this side. If we do that, we have minus 2 root 2r. Then this will come to become minus 2 root 2r as well. Plus 4 minus 4r is equal to 0. So this will give us minus 4 root 2r plus 4 minus 4r is equal to 0. Now let's divide through by negative 4. Okay? Divided by negative 4, divided by negative 4, divided by negative 4, divided by negative 4. We're almost there. All right. So this will remove this. We have root 2r plus, this will give us negative 1. And this will give us plus r, negative, negative, and this is 0. All right. Now, let's write this way. Root 2r plus r minus 1 is equal to 0. Remember, we are looking for the value of r. And we are almost done. I pray I did not make any mistake anyway. Okay. So let's transfer this to this side. We will have root 2r plus r is equal to 1. Let's factorize r out. R brackets root 2 plus 1 is equal to 1, right? So let's divide both sides by root 2 plus 1. So this will remove this. We have r is equal to 1 over root 2 plus 1. Now, if we rationalize this using the conjugate of this, we are going to multiply it by root 2 minus 1 over root 2 minus 1. So we are going to have r is 1 times root 2 minus 1, which is root 2 minus 1, divided by, now applying difference of 2 squares to the denominator, we are going to have root 2 squared minus 1 squared. So we'll end up having root 2 minus 1 over root 2 squared is 2 minus 1 squared is 1. So finally our r will be root 2 minus 1 over 1, which is equal to root 2 minus 1. Thank you so much for watching. See you in my next video. Bye.